Okay, good morning, good afternoon, good evening from Helsinki, and welcome to the Pulse of Networks webinar series. My name is Klaus Still, and I'm the CTO of Creanord, and I will take you to this presentation. So this month is Critical Communications Month in Creanord, and the topic of today is how you can use active data to create outperforming critical communication networks. But before we start, so I want to take the opportunity to advertise that we will be participating in the Critical Communications World in Madrid from the 3rd to the 5th of November. And you can meet our CEO, Jari Agustin, there at our booth. So if you are in Madrid at that time, please come and see us there and find out more on how you can make your networks outperform. Okay, so let's start with today's topic. Let's start by looking at some typical critical communication network types where our solution is used today. On the upper right side, we have utility networks, where the communication typically would be sensors and control traffic. There on the left, we have the railway networks, where again, there's mainly sensor and control traffic being transmitted. On the bottom right side, we have a mining industry example where the traffic, except for the highly critical sensor and control traffic, could be also some voice traffic as well. If we consider a fourth category, like public safety networks, also the voice traffic there is highly critical. And all of these scenarios today are characterized by fairly well-behaving traffic streams. So the main focus today in terms of quality is to measure just the availability of the service. That's quite natural, of course, as this traffic is very critical and you need to make sure the traffic is flowing 24/7. So you need to have very high availability figures. Now, this situation will change with the introduction of 5G. So the 5G technology offers a lot of possibilities to invent in terms of the types of use cases that you run over these 5G networks. So with the ultra reliable low latency communication traffic, that is of course perfectly suited for critical communication needs. And in addition, the 5G offers also huge increases in the traffic capacity and the throughput. A third advantage of these networks are the massive machine type communication improvements with the capabilities to have 10 to 100 more device densities and also with highly energy efficient IoT communication options. And last but not least, so the enhanced security features of 5G combined with the private networks capabilities and slicing are perfectly suited for critical communication use cases. On this slide, I have just a few of the new use cases enabled by 5G. So first off, drones will be highly important, actually in many scenarios. So with the drones, you can get an overview of the situation, for instance, in an accident, and help the first responders to focus on their highest priorities. At the same time, these drones provide information also to the dispatch center and help the people there figure out whether you need more resources and where to send them. But of course, drones are also very useful for many other scenarios as well, for various surveillance tasks. E-health use cases could be, for instance, live high-resolution video feeds from ambulances, combined with data from the medical equipment to feed information to remote doctors at the hospitals to help them diagnose the patients even before they arrive at the hospitals, and potentially even start the treatment of the patient before he or she arrives at the hospital. And finally, a third scenario is augmented reality, which offers a lot of promise to help, for instance, firefighters in real to get real-time visibility in zero visibility environments when there's too much smoke to otherwise function efficiently. And you can, of course, combine a lot of other useful data as well to the firefighters in that augmented reality. So these new use cases introduces also new network challenges in terms of managing the performance of the network. So particularly if we look at the video streams, they are quite bursty in nature and may also affect the performance of the other data streams carried by this network. So on the slide here, I have an illustration of the traffic patterns for a 4K video streaming feed, adaptive bitrate stream. And as you can see from the picture, the traffic is quite bursty. And these bursts in the video feeds can introduce, for instance, packet loss or significant additional delay to the other traffic flows on the same network. So this will really transform the way you should manage the network and manage the performance of the network. It's very vital in these new scenarios that the performance monitoring solution not only monitors the availability of the service, but also focuses on monitoring other quality indicators of the services, such as jitter, delay, and loss. Here we just summarize again the traffic mixes and requirements for some of the new use cases for the critical communication networks. And as we can see on this slide, again, of course, the available requirements are still very high also for these new use cases, but also the nature of the traffic is in many cases real time or near real time. So there's a lot of strict requirements on the delays as well. And the data rates are, for many of these new traffic types, data rates are also high. So meaning that it will put significant strain on the network and put a more risk for quality issues. How do we address these challenges? There are 4 parts to the solution, and I will be describing these more in detail on the following slides. Number 1, validate the performance for the new services before taking them into use to make sure that the network can carry these new services before and perform as required. Number 2, actively monitor the service quality accurately down to the microsecond level and continuously validate the quality of service and quality of experience. Number 3 is to proactively engineer your network to meet the future demands of the network. To stay on top of the network performance, you need to be able to also predict the issues before they actually happen. And finally, it's also important to verify the performance of the networks against set performance targets, and to have SLAs to offer to end users to prove the network performance and build trust that for instance, a 5G slice is performing as expected. The same reports can also be used for internal purposes to continuously review the network and fix potential issues. So let's have a deeper look at each of these parts. And well, first off, with validating the service, so the idea is really that you run a service test before you actually take the service into use with traffic profiles that simulate the real traffic that will be running on the network. And these tests also offer birth certificates, which can then be used as a proof of that the network is ready, and also offers a baseline that you can use to compare in the future to what the network is actually doing. And it also offers the opportunity for you to particularly in these critical communication networks, to do worst case analysis, where you are simulating worst case traffic scenarios, and also look at how the network is performing in these cases. Particularly important, of course, as you are taking 5G technology into use to really build the trust that the network can perform. This service activation suite consists of 4 different tests: the Y1564, RFC 2544, RFC 6349, and IPERF 3. So let's have a look at these tests a little bit more in detail. So the Y1564 is a ITU-T defined standard, and is very good also for the 5G testing. You can simultaneously test multiple service class flows in this test, so you can really simulate various traffic scenarios, control traffic, voice, video traffic, etc., and run this simultaneously and see how the network is performing. And you can do this test both on layer 2 and layer 3. And as mentioned before, is you also get the birth certificate as a kind of a certificate that the network is performing as required. The RFC 2544 is an IETF specification, not as suited as the Y1564 for service testing, but is good for basic network performance testing. It was really originally designed for device performance testing. So it's a valuable tool as well for let's say basic performance testing. But you have some limitations in terms of how many flows you can test. So it's just for one flow. Then the RFC 6349 and IPERF 3 can be further used once for the basic network performance is validated, to also validate specifically TCP type of traffic. So these tests run on layer 4, and you can simulate to very large numbers of TCP flows, particularly with the RFC 6349. And why it's important to run also these tests is that even if the network is basically performing well, even small performance degradations can have big impacts on the TCP traffic performance. So if a lot of traffic is TCP based, it really makes sense to run these tests as well. And number 2 was to actively monitor the network. So once you have verified that the network is performing as expected and taking your services into use, then of course you need to continuously monitor the network and make sure that it's performing as required. So and have active monitoring that have granular enough granularities so that you can identify microbursts and find the performance degradations and outages. And quite important here for the real-time requirements of the critical communication network, the accuracy of the measurements are very important. So you need to go below the millisecond down to the microsecond levels to ensure the performance of these vital services. And important is also that you're not only generally validating the performance, but also looking into each of the different service classes. As we saw earlier, there is a quite challenging traffic mix, and which means that you need to put a lot of focus on your how you manage your differentiated services, and you need visibility into each of the different service classes and to see how they are performing, both on the video control traffic, voice, etc. Tools in the active measurement suite are really TWAMP, net precision, and the user experience application monitoring tools. So if we have a deeper look at this, we have the TWAMP protocol, two-way active measurement protocol, defined by the IETF. Nowadays, implemented in you can say in all of the major network element vendors' equipment, and it allows you to monitor thousands of test targets from a central location. So making it also very efficient to deploy just one central probe and monitor a large part of the network. And with the TWAMP, you really get timestamping down to the microsecond levels that you need for these scenarios. We also have a Creanord optimized TWAMP protocol, the net precision, which is similar to the TWAMP, but just enhanced for core network monitoring and to get better scalability and a better accuracy also for the one-way measurements in this case. And then thirdly, in addition to monitor the basic network performance, it's also important to go up to the application level and see how the users and software applications are running on top of the network, and measure things like if you are connecting to various application servers, internet, etc. So to see that all of these basic infrastructure services are working well as well, in addition to the general network performance. Then the third step is to not only actively monitor the network, but also get proactive about the monitoring and to engineer the network and make sure that you react to issues before they actually happen. So we have three tools here in this suite. The first thing is, of course, to set thresholds to define when warning levels and failing levels, when you should really react to performance degradations, and then your system will continuously verify these targets. Second level is really to have baselines as well, where the system will automatically learn the traffic patterns of the network and then report if the network is deviating from these baseline measurements. And the third tool is really to look at trend lines as well, so that you can find trends in the network to identify when you have potential bottlenecks or future performance issues, so that you can fix them before your services are actually affected, and re-engineer your network based on these trends. So if we look a bit closer on these tools, you have the threshold profiles. Typically, you can set thresholds on the jitter, delay, and the packet loss. And then the system will continuously verify the service performance against these configured profiles. And you can have you define then different profiles for each of the service classes, so that you can also make sure that you are monitoring each of the different service classes based on their performance requirements for the video is quite different requirements than for voice or control traffic. And based on that, you both get real-time alarms to react to issues, and you also get it's also a basis for the service availability calculation. So when you want to see how well the services have performed. Then the baselines. So these are automatically machine learned by the system by looking at historical data and then calculating a baseline, how the network should be performed at certain times of the day. And then you can define the deviations and both in terms of percentages from the baseline or absolute values. So if the network is 5 milliseconds slower than it usually is, then you should get a notification. So this is quite valuable as well as of course the performance can vary at different times of the days. And also these baselines are not set, but they are continuously modified as the network evolves and the traffic patterns evolves. So the system will automatically then update the baseline based on the new traffic profiles. Then the trend lines. So the idea there is really to identify macro trends in the network so that you can predict future performance issues. It's also quite useful, for instance, in cases where you do some major modifications to the network. So then you can see on the macro level whether this change had an impact on the overall performance or not. So you can look at if the trends are changing dramatically after the change. And you can also have views where you are looking at many different categories or traffic scenarios in the network and identify trends from that by service class or by traffic types, etc. And the fourth tool is really that you need to look at this is also to verify the performance of the network, just not monitor, but you also need to verify that. And there's three tools in that suite as well. So you have a real-time dashboard where you can view performance summaries in real time against these targets or thresholds that you configured for the different service classes. We have the SLA delivery, which then calculates the SLA reports on a daily, weekly, monthly basis. And these reports are quite important as we move to a new 5G technology. So you can provide an SLA report for the service, prove and build the confidence that the 5G network is really performing as expected. And both to the users of the 5G slice, but of course also internally for your internal purposes to continuously verify that you are meeting the targets that you have set. And the third is really to have also the ability to share this information with the end users through a customer portal, and also this portal offers the opportunity that you see the status of the network in real time, for instance, and events in the network, etc. So that the end users have a very real-time view on how the network is performing as well. So yeah, like talk, the dashboard will summarize your service performance and show you a status of the network, and you can do many different views of the network by customer view, by geographical area, by the service classes, by the different critical communication use cases, etc. And from this real-time view, you can then drill down to the individual service performance views and do the more detailed troubleshooting and find out if there are potential issues in the network. In this SLA delivery case, so you can get Excel format, so meaning it's very easy to share internally and externally, and important is also that you are not only calculating on a monthly basis, but you also want to have weekly and daily reports so that you are reacting quickly to changes in the network in case you are starting to see issues. And these reports can, of course, then be automatically shared through the customer portals or emails or through the external interfaces. And as I said, the customer portal is then important for the real-time communication with the end users to have a view of the network, both in terms of what's actually happening right now in the network, as well as having the historical view on how the network has performed in the form of these SLA reports. So Creanord has made a Pulse Shore solution, and which will provide you these tools that we have went through to really have a comprehensive set of service quality monitoring capabilities, and through this tool, so you have a full view of how your network is performing, and you can make sure that you both see in real time what's happening, as well as predicting and reporting and verifying how the network is doing through the whole service cycle. What's good is also we are technology vendor agnostic, so we fit in any type of technologies, and we're field proven in more than 50 service provider networks nowadays. Actually, more than 60. More accurate number. Okay, so to conclude, so with the 5G, you have a lot of new critical communication use cases that will actually introduce new and challenging traffic mix to the network, and challenges to manage these traffic streams. And to do that, you need really advanced performance monitoring tools to manage these networks, and Creanord has the tools that you need to really implement a holistic solution in a cost-efficient manner. Okay, that's all for today. So if you have any questions, so please send an email to me, or check out our website, and we have more webinars coming, so check them out as well. Contact me or sales, and we'll explore more on how you can create outperforming networks. Thanks a lot. Bye.